There is a type of sand in the Sahara that does not belong there. Not philosophically, not metaphorically. Literally, it does not belong there. Stretched across thousands of square kilometers of Egypt and Libya is a field of silica glass. Glass that requires temperatures above 1,700 degrees Celsius to form. Temperatures that do not occur naturally at ground level. Temperatures only a meteorite impact could produce. Except, there is no crater. Geologists have searched. They've modeled the geology. And the impact crater that should exist beneath this vast field of fused glass simply doesn't. That's where the official story stops. But something happened to North Africa. Something transformed it from what it once was, a vast, humid, forested land the ancient Egyptians called the land of plenty, a place Roman writers described as the breadbasket of the Mediterranean, into the largest hot desert on Earth. And the timeline of that transformation doesn't match any natural desertification process science has ever recorded. The Sahara did not dry out slowly. It did not transition gradually. In geological terms, it collapsed. We know the Sahara was once green. Not theoretically. The pollen records are there. The lake's sediment cores make it undeniable. There were elephants, hippos, giraffes. Rock art in the Tassili Integer Mountains shows human figures swimming in what is now bone-dry desert. Palea Lake Megachad once covered an area larger than the Caspian Sea. The Niger River had tributaries that no longer exist. Between 6,000 and 4,000 years ago, all of it ended. The conventional explanation is orbital precession, the Milankovitch cycles. As Earth's orbital tilt shifted, the monsoon rains retreated south. The lakes dried. The land followed. Orbital forcing is real. It's documented. But here's the problem. It predicts a gradual transition. What the sediment cores actually show is something closer to a step function, an abrupt collapse. A rapid state change that orbital models alone cannot fully predict. Something accelerated it. When industrial mining strips a landscape, it leaves behind tailings, processed waste, ground rock, chemically altered residue of whatever was extracted. Tailings piles are enormous. The copper tailings of Chile's Atacama have altered the soil chemistry across regions the size of small countries. From above, they look like devastation. They look like dead land. They look like a desert. Now look at the Sahara. Beneath the sand, satellite imaging and seismic surveys confirm one of the largest phosphate deposits on the planet. Western Sahara alone holds an estimated 70% of the world's known phosphate reserves. The Saharan substrate is rich in iron ore, manganese, uranium, and rare earth elements. But here's what's stranger than what's beneath the sand. It's the sand itself. Sand formed by long-term wind erosion should show a mixture of mineral types. Grain sizes reflecting how far they've traveled. Variable composition reflecting the surrounding geology. Saharan sand, in the massive central sand seas, the ergs, shows something different. A type of silica sand that is too pure. Mineral uniformity at a level that geological processes over the time available should not have achieved. A grain-size distribution that looks less like natural transport and more like mechanical sizing. The purity profile of industrial-grade silica, the kind used in glass manufacturing, in semiconductors, in hydraulic fracturing. Natural processes cannot fully explain this. Which brings us back to the glass. 6,000 square kilometers of fused silica glass. No crater, no volcanic source, no conventional explanation that fully accounts for all the evidence. The current working hypothesis from mainstream science, an airburst, a comet or meteor exploding above the surface without impacting, could have generated enough radiant heat to fuse the silica on the ground below. That's viable, but it's also an event of civilization-ending magnitude that left behind, beyond the glass field itself, almost no other evidence in the regional geological record. An alternative hypothesis, and I'm not telling you what to believe, I'm telling you what the evidence raises, is this. What if the glass is slag? Slag is the fused residue of industrial high-temperature processing, a byproduct of smelting, refining, extraction operations. If something processed silicon-rich material in this region at temperatures above 1,700 degrees Celsius, the fused waste product left on the surface would look exactly like what we see in the Libyan desert. Not a natural formation. A remnant of an operation. In the 1980s, NASA's Space Shuttle Imaging Radar missions produced maps of the Sahara's subsurface that changed everything we thought we knew. Beneath the sand, an interconnected system of ancient riverbeds, channels, and lake basins so extensive it's been called the invisible river system of North Africa. The conventional reading: these are remnants of the Green Sahara's river systems, buried by millennia of sand. That's almost certainly partially correct. But within the imaging data, researchers have identified channel systems that don't connect to any rainfall catchment area. They begin in flat terrain and end in flat terrain. They maintain consistent widths over long distances, something seasonal rivers don't do. Several of them simply stop. Not at a coast, not at a basin. They just stop. Rivers don't do that. But pipelines do. Infrastructure built to carry material from one specific point to another does. In the Ahaggar Mountains of southern Algeria and the Tibesti Mountains of Chad, ancient volcanic formations. Surrounding them are drainage systems called wadis. These wadis radiate outward from central high points in patterns too regular for rainfall. And some of them don't terminate at a drainage basin. They terminate nowhere natural. What the geology would look like if these were not river channels formed by water cutting downward, but drainage patterns formed by something being pulled upward and outward, with soil following in the spaces left behind. That's a different kind of channel entirely. Across North Africa, there are circular formations in the geological record. Perfectly circular depressions surrounded by a ring of elevated terrain with a flat base. Official classification: meteor craters, ancient volcanic calderas. But look at the proportions. The relationship between depression diameter and surrounding wall height. Then look at the cross-section of a tree stump, the root bowl. The way a massive tree, when its root system decays or is removed, leaves behind a circular depression in the earth. The rim of elevated terrain is not an impact ejecta ring. It has the proportions of compressed soil around the base of something that stood there and is no longer there. The Eye of the Sahara, the Richat structure in Mauritania, approximately 50 kilometers in diameter, visible from space. Concentric rings of different rock types in a pattern so geometrically regular that the first astronauts to observe it thought it was an impact crater. Geologists studied it and concluded it was not. The rock types were wrong. The deformation patterns were wrong. It was reclassified as a symmetrical anticline, a dome of rock pushed up by geological pressure, then eroded to reveal concentric layers. The Gilf Kabir Plateau in southwestern Egypt, a vast sandstone plateau cut by deep valleys. The walls of the plateau, in certain sections, show regular vertical striations. Official geology attributes them to differential erosion. Non-specialist observers consistently identify them as tool marks, parallel cuts at consistent intervals and consistent depths, the kind of marks left by a cutting implement rather than by differential weathering. None of this is conclusive in isolation. The power of putting it together is in the pattern, not that any single anomaly proves something, but that multiple anomalies across the same region, producing similar signatures, are harder to explain by multiple unrelated natural causes than by a single sufficiently powerful artificial one. Here's the part of this that's hardest to sit with. Certain plants accumulate silicon in their biological tissue as structural reinforcement. Horsetail plants, whose ancestors dominated the Carboniferous forests, accumulate silica to the point where dried horsetail can be used as a natural abrasive. Bamboo accumulates silica. Most grasses accumulate silica. An organism of truly extraordinary scale would need structural materials proportionally more robust than anything in the modern plant kingdom. Silica accumulation at massive scale is one candidate. If such an organism existed, and if the silicon content of its tissue was extraordinarily high, then an extraction process targeting that biomass for its silicon would strip enormous quantities from the biological matrix. What would remain would be the non-silicon organic fraction, which in an environment stripped of moisture cycles would desiccate and disperse. It would become dust. Saharan dust is the Amazon's primary mineral nutrient source. This is not fringe, it's documented science. The massive plumes blowing westward from North Africa across the Atlantic deposit minerals into the Amazon basin annually. What if that dust is the fine fraction of something that was processed here thousands of years ago, and what blows westward is what remained after the extraction? The tailings, blown by the wind, still feeding the world's largest rainforest. Let's be clear about what I'm not saying. I'm not saying any of this is proven. I'm not asking you to accept a specific historical narrative. What I am saying is this: the anomalies are real. The Libyan desert glass is real. The purity of the silica is real. The subsurface channel systems that don't behave like rivers, real. The abrupt termination of the African humid period faster than orbital models predict, real. These are not fringe observations. They are published in academic literature. They are debated at geological conferences. Mainstream science sees them. It just doesn't connect them, because connecting them produces a picture the existing framework has no room for. And the framework is not going to expand without something compelling it to. The Sahara was not always a desert. You know this. The pollen is in the sediment cores. The rock art is on the canyon walls. The ancient channels are in the radar imaging. What ended it is still marked on the surface. The question is whether those marks are natural, or whether they are evidence of something that knew what it was doing, did it completely, and left. The pure silica sand. The glass fields with no crater. The channel systems with no rainfall source. The circular depressions with no impactor. The plateau walls with their parallel striations. These are not separate problems waiting for separate solutions. They might be the same problem. And the problem might be that something very large happened here, and we have been calling it geography. If you want to keep asking these questions, subscribe. New videos every week. Leave a comment. Where in the world are you watching from? And which part of this had you never considered before? History, above all things, is worth questioning.